Question number 11. Equations for some reactions of hydrogen peroxide are given. In which reaction is hydrogen peroxide acting as a reducing agent? Well, so reducing agent means electron donator. Okay, that means something donates electron. That means you have to look for where oxidation reaction is happening. So here iron 2 plus 2 3 plus, it means oxidation. Iron 2 plus is oxidized, so definitely this is not our option. Here Mn 7 plus 2 2 plus, that means this is reduction. That means definitely this is oxidized. This is one of our option. Here iron 3 plus 2 2 plus, so again reduction happen for Fe3 plus is reduced, so H2O2 is our reducing agent. So option 2 and 3. So C is our correct answer. Question number 12. The equation for the reaction of aqueous thiosulfate ions and aqueous dioxyvanadium ions is shown. Which row shows two correct statements about the equation for this reaction? Well, so solve this type of problems, I usually do the half equations. Okay, I think this is the best way to solve this type of questions. Well, so at first we have thiosulfate ion, which is converted into tetrathionate ion. So 2 moles of thiosulfate ion is giving 1 moles of tetrathionate ion. Okay, so we have to calculate the oxidation state of sulfur in each ions. So for thiosulfate ion, how to do it? How to do this thing? So we don't know the oxidation state of sulfur, so 2x plus 3 into minus 2 is equals to minus 2. So x is equals to plus 2. That means the oxidation state of x is here, sulfur is plus 2. And in tetrathionate, tetrathionate 4x plus 6 into minus 2 is equals to minus 2. So x is plus 2.5. That means the oxidation state of sulfur in tetrathionate is plus 2.5. Okay, so each sulfur, in a way, if I can say this way, each sulfur is leaving 0.5 electron. Each sulfur is leaving 0.5 electrons. So at my right side I have 4 sulfur. So 4 sulfur is leaving 2 electron. That means minus 2 electron. Okay, now let's do the half equation for dioxyvanadium ions. VO2 plus H plus ion, VO2 plus ion, and water. Okay, so the similar process, same way I have to find out the oxidation state of vanadium in both sides. So here this is plus 5 and this is plus 4. Okay, so that means it is gaining one electron. Now I have to balance the oxygen. So I have two oxygen at my left side, and right side I have two oxygen. Okay, so now right side I have two hydrogens, so I have to just put it 2 before H plus ion. So now this equation is balanced. But the problem is, if you can see that we have to cancel out the electron. So at the top equation, first equation, I have 2 electron, but at the bottom I have 1 electron. So I have to multiply this whole equation by 2. So balancing number will be 2. It will become 4. This is 2, 2, 2. So my electrons are cancelling out each other. So we have got the value of x, y, and z. X is 2, y is 4, and z is 2. So first of all, the oxidation state of vanadium from +5 to +4. So this two are already cut it out. I have to check for this. X and z at the same value, and quarter of the y, no. X and z at the same value, and the half of the value of y, yes. So C is our answer. Question number 13. When some solid, something like that, is added to a beaker of water, an equilibrium is set up. Okay, the chemical equation is given. Which compound, when added to the equilibrium mixture, increases the amount of this is reactant present? Okay, so if you check this out, that in this reaction OH minus ion is being produced. Okay, and these are in the aqueous state. So if you increase the alkaline, I mean if you make it more alkaline, then definitely it will favor the backward reaction. So in this is an acid, this is neutral, this is kind of neutral, if I say this one. Okay, so question number 13, answer of the question number 13 is A, addition of an alkali. Okay, question number 14. Gaseous hydrogen and gaseous iodine react to form gaseous hydrogen iodide. In an experiment, 2 mole of hydrogen and 2 mole of iodine are placed in a sealed container of volume 1 dm cube. Kc of the for this reaction is given, that is 9. How many moles of hydrogen iodide are present at equilibrium? Okay, so we always do this type of reaction by developing the ice table. Okay, what is ice table? It will show the initial concentration, change in concentration, and the concentration at equilibrium. Okay, so the initial is 2 mole per dm cube and 2 mole per dm cube. So initially there was no product, right? So we don't know the change. So for example, the change is x mole, x mole. So by using the mole ratio, we can say that when 1 mole of hydrogen is reacting with 1 mole of iodine, you will get 2 moles of hydrogen iodide. So when the changes in x mole, definitely 2x mole will be produced. So at equilibrium, 2 minus x mole per dm cube hydrogen, 2 minus x mole per dm cube iodine will remain, and 2x mole per dm cube hydrogen iodide will be produced. So now we have to um, use this value to our formula. So we know that Kc is equals to concentration of the product, hydrogen iodide, and 2 moles, so it will be go to power the concentration of the reactant. Okay, so the value for Kc is given, hydrogen iodide 2x whole square, and both of these values are same, the concentration of hydrogen and iodine at the equilibrium. So this is 2 minus x whole square. Okay, so let's just do some mathematics here. This is 3 is equals to 2x 2 minus x. Okay, that means I am bringing this square value to my left and making it root over 9. We will get 3. So 2x is equals to 6 minus 3x. 2x plus 3x is equals to 5x is equals to 6. So x is equals to 6 by 5, that is 1.2. So x is 1.2 and the amount of hydrogen iodide at equilibrium is 2x, so I have to multiply this by 2. This is 2.4. So the answer is D. Question number 15. Why does the rate of gaseous reaction increase when the pressure is increased at a constant temperature? More particles have energy that exceeds the activation energy? No. The particles have more space? Definitely no. Particles move faster? No. There are more frequent collisions between the particles? Yes. Answer is D. Question number 16. The Boltzmann distribution for a mixture of gases capable of reaction is shown. The two curves represent the mixture of gases at 25 degrees Celsius and 35 degrees Celsius. Active heat energies for the catalyzed and uncatalyzed reactions are shown. Okay, so definitely this one is 25 degrees Celsius and this one is for 35 degrees Celsius. Okay, so this is uncatalyzed, this is catalyzed. Okay, which row is correct? So number of particles with enough energy to react at 25 degrees Celsius, number of particles with enough energy to react at 35 degrees Celsius is uncatalyzed and this is catalyzed. Okay, so if we just check this one, number of particles with enough energy to react with 35 degrees Celsius in uncatalyzed reaction. Number 35, that means this one, uncatalyzed number of particles, that is x plus c. So this one are already cut from our option, x and z. Okay, now number of particles with enough energy to react at 25 degrees Celsius in the catalyzed reaction. So catalyzed reaction 25, so this one, this amount and this amount, so y plus g, this one. So correct answer is D. Which question number 17, which oxide is insoluble in aqueous sodium hydroxide? alkali. uh, Non-metal oxides is insoluble. Acha. So non-metal oxides, this is basic, so it will be soluble. This is non-metal oxides, it will be soluble. This is amphoteric, so it will be soluble also. Magnesium oxide, metal oxide, this is also basic, so it's not going to be soluble in sodium hydroxide. So the answer is A. Question number 18. Sodium and sulfur are burned separately in oxygen. Each reaction has a distinctive flame color. Sodium, so between C and D, sulfur, blue flame. So answer is C. Question number 19. X and Y are element in period 3 of the periodic table. Y has greater atomic number than X. It means Y is the right side of the periodic table. So greater atomic number of X, that means X has greater atomic radius. Okay, yeah, across the period atomic radius decreases, so either A or C. B and D are already out of our option. The stable ion formed by Y has a greater radius than the stable ion formed by X. Stable ion formed by Y has 18 electrons. Okay, as they have difference in the ionic radius, so and Y has the greater ionic radius, so we can guess that Y is the non-metal and X is a metal. So if Y, moreover, Y has 18 electron, so definitely X cannot have 18 electrons, so the correct answer is A. Question number 20. X is a group 2 element in either period 3 or period 5. X hydroxide is less soluble in water than calcium hydroxide. X hydroxide is less soluble, group 2, either period 3 or period 5. So period 3 means this is magnesium or strontium. Okay, so calcium is in between these two. So we know that group 2 down the group hydroxides solubility increase as X has lesser solubility, so this X is Mg. When X nitrate is heated, it decomposes. Okay, so definitely C is out of our option, and when this decomposition happens, metal cannot be produced, so correct answer is B.